to them to give their short presentations of about 10 minutes, and then we'll have a discussion at the end. So our first speaker, I'm going to introduce all the panelists first and then bring the speakers on board. So that way you'll get an idea of what we're going to talk about. So first of all, we have Anna Persic from UNESCO, and who will talk about the UNESCO recommendation on open science, the context, the timescales and implications, and how to engage and support this. The UNESCO recommendation is a major event in open science at the moment, and Anna will explain the significance of that, but that's a way of starting the panel so you understand these developments. Then Li Tong, who's a consultant with CoData, will talk about data policy developments apart from the UNESCO recommendation, the idea of the FAIR principles, very importantly for our Chinese colleagues, the Chinese State Council Scientific Data Management Measures, and give an introduction to a review that CoData is conducting of the CAS-Earth data policy. And it will be important to communicate that information and to discuss that review. Then we have Li Jianhui, who's CoData Vice President and works at CNIC, part of the Chinese Academy of Sciences. And he'll introduce that CAS-Earth open data policy in practice. And it will be important for us to understand the implications of that, where that sits, and how that can help advance science for the SDGs and using Earth observation data. Then we move on to two experts who work, two international experts associated with CoData who work in the area of open science and fair data for Earth observation. First of all, Bapan Fakhruddin, who's the chair of one of our task groups on disaster risk reduction, and then Ayona Rybkina from the Geophysical Center at the Russian Academy of Sciences, who's also CoData Vice President, and we'll talk about her involvement with the GEO initiative, the Group on Earth Observations, and their data working group. And so that will be two international perspectives about open data and fair data in relation to Earth observation studies. And then finally, I'll wrap up the presentations by introducing all the participants to the Global Open Science Cloud initiative, which we think will be of interest. And then we'll have discussion and questions. So I hope that run through of what we're going to do is interesting. And I'll hand over to Anna Persic, to tell us about the UNESCO recommendations. Anna, over to you. Great to see you.
Thank you very much, Simon, and thank you, colleagues, also for the invitation. It's really a pleasure to be here in this event and to tell you a little bit more about where we are with the UNESCO recommendation on open science, and what is the implication of this recommendation for our future work on open science. So I'm going to share my screen very quickly. And Simon, please feel free to stop me if I'm talking too much. But I would like to really tell everybody where we are with the recommendation, what it is, and what it's going to do for the global community of open science. But just before we start, I do want to put this recommendation in the context, particularly in the context of the United Nations, and why UNESCO as a UN agency has embarked in this policy work on open science. It's because we really see open science with a great potential to increase the quality of science and to make sure that the entire scientific process is more transparent, more collaborative, and more inclusive, and in that way responds to the current needs of society and humanity better. We also see it as an important accelerator for the United Nations Sustainable Development Goals. And also, if done correctly, open science as a new way of doing science can really help in bridging the science technology innovation gaps that we see within and between nations. And also, it can be an important tool to fulfill the human right to science. And I think the current COVID pandemic has really put forward and showed the importance of science for the benefits of society, but also the importance of the human right to science and to benefit from the application of science and scientific progress. We also see more broadly in the past decade, really this movement of open science growing in its different components. Let's say we have open access, we have an open data, we have some other components, let's say, of open science. In terms of open access, we see that the percentage of publication in open access, in some kind of form of open access, has really been growing steadily in the past decade. But we still have a lot of publications that are behind some sort of paywall. And we also saw that that is something that can be changed, because just in the case of COVID, we do have almost 70% of publications which actually are in open access. So that percentage can actually shift quite quickly. And we're trying to understand what are the ways in which the global science community can be pushed so that this open access is increased even more. We also see that the open science repositories are expanding globally, so both in terms of open access repositories, but also in terms of open data repositories, so the trends are there. But we can also see from these two world maps that there is a huge disparity in terms of where the presence of these open science repositories and the need to basically fill these gaps as well. And more broadly, we do still see gaps in both open science and science technology innovation more broadly, and in terms of investment in science, particularly between the global south and global north. And that is something that needs to be changed, and where open science can play an important role. But as I said, for open science to really meet its potential, it has to be done properly. It has to be done in an equitable way. It has to ensure that this new way of doing science really closes the knowledge gaps between nations, and it doesn't widen them even more. That is the reason why in November 2019, the UNESCO General Conference, which is the body that governs UNESCO with 193 member states, they've decided to task the organization with the development of an international standard-setting instrument on open science, a UNESCO recommendation on open science. So it's a policy instrument that provides policy framework and is supposed to induce changes, legislative also changes for the different countries that adopt it, in order to have a common definition of open science, to have a shared set of values and principles, and a shared set of actions that need to be taken by open science community as a whole, in particular the member states, to ensure that open science, as I said, meets its potentials. So the idea in November 2019, and that was right before the start of the COVID pandemic, was to look into this recommendation, to have a broad consultative process to come up with a draft text of the recommendation that would then be hopefully adopted at the next session of the General Conference, which is actually now taking place in November this year. So for 2 years, we've had a broad consultative process trying to get inputs from different regions of the world, from different communities involved in open access, in open science, to get a broad overview of what open science is, what it means, and how it should be done. The process was also guided by an open science advisory committee. Simon is part of that. We have other 29 colleagues who are part of the advisory committee, and they have been of great help in putting together this text and this entire process. We've had global consultations, received inputs from over 130 countries, regional consultations in Africa, Arab states, Latin America, Asia Pacific, Eastern Europe, Western Europe, and North America. It was extremely important to get feedbacks from all over the world. We've had thematic and stakeholder consultations with young scientists, citizen science, academies, science unions, libraries, data organization, UN system, and indigenous people. So we really tried to be as inclusive as possible, because open science really is about opening science to society, and vice versa, opening society to science. It is also part of an intergovernmental process. So in May this year, we had an intergovernmental meeting of experts who actually negotiated and adopted the final draft text of the recommendation. There were over 100 countries represented, 65 observers from all over the world, and also from all kinds of different backgrounds. Lots of interest in this recommendation, lots of interest from different communities to really come up with a policy framework, global policy framework that would put many of the notions of open science, component of open science, and principles of open science together in one place to guide the national plans and other institutional ways to do open science. So in the current text of the recommendation, and maybe I can share it also later in the chat for everybody to know what we are talking about. In this current text of the recommendation, the open science is defined as a tool to increase scientific collaboration, sharing of information for the benefits of science and society. It makes scientific knowledge openly available, accessible, and reusable for everyone, and opens the process of scientific knowledge creation, evaluation, and communication to societal actors beyond the traditional scientific community. As such, it has different components, what we call the pillars of open science. Open scientific knowledge. We're talking here about open access to scientific publications, open research data, open educational resources, open source and source code, and also open hardware. Then the open science infrastructures, including both virtual and physical infrastructures. Open engagement with other societal actors beyond the scientific community through crowdfunding, crowdsourcing, citizen science, participatory science, volunteering, etc. And then this open dialogue with other knowledge systems, including indigenous peoples, local communities, and also marginalized scholars. So you can see here from this definition of open science that it really is a broad concept that changes the way the scientific systems work, and the way in which science kind of engages not just for scientists, but also with the rest of the society. It really is about opening up collaborations, and it really is about creating together and increasing access and having more equity in terms of access to scientific knowledge, data, and applications. We've spent a lot of time looking into the values and principles for open science. So the core values are now identified in the draft text and explained also, so that we really, all of us, know what we refer to when we talk about quality and integrity in terms of open science, collective benefit, equity and fairness, and diversity and inclusiveness, which have been identified as the core values for open science. And then we have a series of principles: transparency, scrutiny, critique, equality of opportunities, responsibility, accountability, collaboration, inclusion, flexibility, and sustainability. So these are really the principles and core values upon which the open science practices should be implemented and developed. Also, another part really important of the recommendation is a series of actions. These actions, as I said, are intended for governments, but not only for governments, also for other open science actors. There are 7 areas, and under each area, there is a series of actions that will have to be implemented as we go along. The areas of actions include promotion of a common understanding of open science, of creating an enabling policy environment, investing in infrastructures and services, investing in human resources, capacity building, promoting cooperation, innovative approaches, and fostering more broadly a culture of open science. So again, it gives a pretty broad picture of what needs to be done, but it is important to have that broad picture so that each and every action actually does fall within this broader open science system. In terms of next steps in the process, we are now at the end of the development process. And as I said, in November, we are hoping that the member states that will be meeting they will discuss and hopefully adopt the final text of the recommendation. And then from the 1st December on, we can start with the implementation. And of course, in the implementation, we will go back to the Open Science Partnership. We will go back to everybody who provided inputs into this draft text. And most importantly, we will go back to those who are actively engaging and working with open science, including your community. There are several issues with open science that we collectively have to look into while implementing the recommendation. There are issues with regards to maintaining the research quality, integrity in an open science context. There is the central issue of capacity building, for which definitely all the partners will be informed. The importance of adequate infrastructures, internet connectivity, alignment of incentives, revision of criteria for evaluation of scientific excellence, the links between intellectual property rights and open science, links with the other knowledge systems, the importance of international solidarities, and then some of the risks which can be associated with the commercial monopolization of research data, and also the supporting services and infrastructures. And of course, there is an issue of monitoring of open science. So again, I'm going to stop here and thank you for your for listening. But please do keep your eyes and ears open about the latest on the recommendation. And hopefully, as I said, if in November the member states do agree and adopt it, there's going to be a lot of work for everybody to make sure that we implement the recommendation also through your actions as well. So Simon, I'm going to stop there. I hope
that's great. No, that's great. Thank you very much, Anna, and I think that's an excellent overview of the recommendation, its considerations, and the progress. Before I hand over to the next speaker, we've got an interesting question from one of our panelists, Zhenhui, and you've covered this a little bit with that time frame at the end, but Zhenhui asks, does UNESCO have a concrete plan to mobilize and encourage the practice and the implementation of the recommendation? Maybe you could just very quickly respond to that question.
Yes, I mean, we definitely have a concrete plan, and it is something that we will be working on in the months to come. Obviously, for the moment, we have been very much focused in our division here in this part of UNESCO on developing the draft recommendation, on developing this whole community of practice around the open science that then we can call upon when it comes to the implementation. So at this stage, we really want to see how it plays out with the member states. We do hope that there will be no issues and then the recommendation will be adopted. And after that, as I say, as of December, we are looking into an implementation plan that we will be sharing and also, again, co-creating with the different partners, because the idea, and I think this is what worked in the process of development of the recommendation, is that we really did not have any preconceived ideas of how the recommendation should look like. And we saw from the open science community and actors what should be in there. The same is for the implementation plan. We now have the recommendation. It gives us the framework, but how the different partners want to engage and through which types of actions, it's something that we still want to kind of tease out with the different partners as well.
So it's a framework to which nations and institutions and research communities can respond and find that place. That's great. Thank you, Anna. So we'll pass over to the next speaker, please, which, as I said, is Li Aitong, who's going to tell us about policy developments outside of the UNESCO recommendation over the past few years and about the co-data independent review of the CASERF data policy. Li Aitong, over to you.
Okay, I will get started. And first, please let me share my slide. And please wait a moment. Okay. Good. So can everyone see my slide?
Yes, that's great. That's working fine. Thank you.
Okay, I think I will start it. So I actually representing our review team to present here because my time is limited. I just go straight forward to my contents. So today I'm going to talk about declarations and policies for open science and open data in the past 2 decades, and explain a little bit about the FAIR principles, and also talk about the progress of open science, open data in China, and also just give a brief introduction of our review of CASA's data policy. So let's first look at the policies. So here is a list of declarations and policies for open science and open data in the last 2 decades, from the Budapest Open Access Initiative in 2002, and gradually progressing and to the Science as an Open Enterprise, the Royal Society report in 2012, and to the Open Innovation, Open Science, Open to the World European Commissions in 2016. And eventually, we got this FAIR principle in 2016. So step by step, those declarations and policies laid out the principles, concepts, and languages we use in the FAIR principle, which is configured in 2016. If we look at the progress globally, so we see that we have made a lot of progresses in the past 2 decades. So we can tell that the number of open access policies worldwide has increased, and currently more than 1,000 organizations actually adopted these open access policies. But it's worth noting here that the overwhelming majority of those open access policies are located in Europe, accounting for about 63%, and only 7% is in Asia. So obviously there is a huge regional gap between developed and developing countries in the process in open science and open data. And there is also a disparity in progress and motivation among different disciplines and institutions, among different actors and organizations. So what underlies those disparities is a lack of policy alignment across local, regional, national, and international jurisdictions. So I think among all those progresses, the most important milestone, I guess, is the FAIR principle in 2016. This FAIR principle laid out 4 basic principles for open data. They are fundable, accessible, interoperable, and reusable. According to these 4 principles, the data should be fundable by using a globally unique and persistent identifiers. And the information about the data should be accessible. That is, the metadata should be accessible. And the data should be described in standardized vocabularies so that it could be interoperable with other data sets, And also the data should be accompanied with proper documentation and user license, so that it could be reused by other individuals and organizations. And this FAIR principle actually put a special emphasis on the ability of machine to automatically find and access and process data, in addition to its support to human beings. So under this global trend, China has also made its progress in open data and open science. China's government has announced its own scientific data management measures, and this measure was announced in 2018. According to this new regulation, data from government-funded research should be open to the public, except those involved in state secrets, national security, and individual privacy. And also, any individual or organization using data from government-funded research should report to corresponding scientific data center before publishing the data and a paper in any foreign journal. And following this new regulation in 2018, we got this Beijing Declaration of Principles on Open Science in 2019. This is quite recently. According to this new Beijing Declaration, it is recognized that research is increasingly driven by data. And research data have global public good characteristic. This is very important. And also the principles described in Beijing Declaration are related to fair data principles. This declaration also put a special note on the need to address the divide in scientific production between developed and developing regions, countries. So according to those regulations, principles, Chinese government put forward this CASAS program as a part of its effort to promote big data-driven science. And we could tell that this CASAS program has three objectives, three layers of objectives. The first layer is, of course, building this big data infrastructure. And the goal is building the world's leading big data infrastructure. And the second layer is to use those big data to drive interdisciplinary studies. And the third layer is actually about policy making. It is using big data to construct a decision support system to serve high-level government authorities and solve real-life problems. So I guess the third layer is also very important, especially when we want to connect those big data with the SDG, Sustainable Development Goals. So the big data has to be used to serve the Sustainable Development Goals and to solve real-life problems. So our review of this CASAS data policy is actually, as you see, built on the open science, open data development in the last 2 decades. And also our review of this CASAS data policy is based on our expertise in research data program reviews. We got 3 experts in this team, Robert, Paul, and me. We are using a mix of research methods, including interviews, workshops, bench research, and the independent review of reports. So our report is due in next year, in 2022. So we are still working hard on it. And hopefully everything goes well. And but at this moment, we would like to share you a few concluding observations. So during the interviews and workshops, we find that regarding the FAIR principle, a lot of progress has made in improving fundability and accessibility of the data sets and big data, but more efforts probably are needed in the future to improve interoperabilities and reusability of the big data. And also during our interviews, many Chinese experts mentioned about these cultural barriers. I think they mentioned that China's specific culture may be resistant to open data culture and resistant to open data sharing. So I guess a better rewards and incentive system probably should be designed to improve open science and also to overcome these cultural barriers. So we always keep it in mind that this is a process. So promoting open science is a process from planning to implementation to full-scale adoption, and eventually to the last stage, that is open science, open data as a common practice. And we also want to emphasize during our review that open science for its own sake is not a goal. It is just a mechanism. It actually should be embedded. It has to be embedded in a large scale, more systematic efforts to build a research system. This research system is devoted to foster innovation and creation, to encourage discovery and reuse of scientific knowledge that are more reliable, more effective, and more equitable. So that is my presentation today. Thank you for your time.
Thank you very much, Aitong. That was excellent. I thought you made some really important points there, which I'll just re-emphasize. It's relatively easy with the technology we have to make data findable and to some extent accessible. But to make it interoperable and reusable is a real challenge. And you also made the very important points on that last slide about incentives, which are really important. And also this point, which I think is worth emphasizing to our audience and colleagues, that open science is really just science done properly, because science relies on the availability of evidence and data to verify the findings. So open science is science done properly with the technologies of the 21st century. And I think that came through very much in what Anna had to say as well. So our next presenter is, thank you very much again, Aitong. Our next presenter is Li Jianwei, who will talk about the CAS-Earth data policies and the data platform. Thank you, Jianwei.
Okay, good evening, everyone, or good morning, everyone. It's my pleasure to introduce the CAS-Earth open data policy and our practice. You know, actually, I'm from a Computer Network Information Center, Chinese Academy of Sciences, and as Simon mentioned, I also served as co-data vice president. And I'm very pleased to say I got a new title, Deputy Director General of CBAS. CBAS means the International Research Center of Big Data for Development Goals. So this center was launched just yesterday morning, and President Xi think this is a very, very effective measures to support SDGs. So, I will give a very overview of the CAS-Earth program. And so this is a CAS strategy pioneer research and development program. It lasts 5 years from 2018 to 2022. So the investment almost 1.8 billion yuan. It's so in this big program, so the main objective is connecting the different domain data, for example, the consensus data, the remote sensing data, and even the monitoring data, and so on. And we build a big Earth data cloud platform, and then we will integrate the computing facility and the data analysis tools, and then we support the different domains research. Now we mainly focus on the SDGs. So there are almost over 100 project related to this in this program, and each project they will also do their research, and they also connect the data, and we needed to set up our project policy to to encourage our scientists to share their data. So this is we defined some principles to open data. So in the project level, so we asked all the data must be opened by default, except restriction by the national laws. So we wish all the data, they need, because the data come from the research teams, and they will use data, and they also the share data. So we, after data connected together, we will make some quality control, and we will give them the detailed metadata, and so make them reusable and understandable by the other human beings. And we try to make the data can be used sustainably, and we have to develop some infrastructure and services to support these activities. So so the main goal for CAS-Earth is to try to support the data-driven science and decision-making, especially focus on the SDGs. So we defined a project level policies and even the data curation processes. So we define the guidelines for each project to make a data management and sharing plan. Each year, each project, they should, submit a data management and sharing plan. So they will describe what data they will produce, how much, and how to how to make data control, and when to submit to the platform, and how to share, and so all these informations. And after this data submitted to the platform, so they should follow our core metadata specifications. This metadata specification is for each data set. So the scientists should edit the data, follow the specification, add the metadata to each data set. And after the data submitted to the platform, so we have a team, a data curation team. They should, make a data quality control. They will check the data formats, the metadata, and so on. So make it can be understandable and reusable by the other people. So after the data quality control, so data was published to all the publics. So each one can, access this data, but we also define the use, use policies. The users should follow some guidelines how to use it, how to cite it, and also we will connect the data usage metrics, and we will get some reward. Reward to each project. So I think this is a whole link from from each. We define a DMP. So each project will submit the data each year, and edit the metadata and data quality control and publish, and then we will make some reward to each project. So this is the whole cycle for the project data, open data policies. So all the data was submitted to a platform in order to storage it, and to make the users can use it in the cloud environment. We build a computing facilities for open data. So this is our computing facilities. It's a hybrid facilities integrates the high performance computing and the cloud computing and even the AI computing. So the data, almost over 10 petabyte data has been stored in this cloud environment. So users can use it in the cloud environment. And in order to manage all these different data, so we design and develop a data management platform. It includes the data storage service, the data repositories, and for the remote sensing data, for the in order to support the on-demand analysis. So we developed a data box to manage the remote sensing data, and we provide a data bank that integrates the data analysis algorithms and tools, and users can interactive to analysis data. And we develop a data sharing service systems, so users can find the data and access it, and so on. So this is research data repositories. So each project, they should make a data space. So they should upload their data and add the metadata and set up the data policies, and then provide and so the data can be accessed by the data sharing systems. So this is the users can use this data search service to search to all the data sets in the KSS program. Now there are many users used. I know actually most of the data law is in Chinese version, and we encourage our scientists to to translate the metadata to English. And so even we encourage them, so it's a huge work. Now, only most of data set can be accessed by the, the foreign scientists, because only part of them can be translated to English version. So each data we try to follow the fair data principles, and make each data set can be findable, accessible. Just as Simon mentioned, the interoperable may be very difficult, but so each data set they had a persistent identify, and how to citation and the metadata. And we provide many API for machine to access this data. And we make link to the different data together. We provide the knowledge graph for the data sets, the relationships, and we will make some data recommendations if you related to this data set. So it's easier for the users can very easy to find more data related and maybe use it together. And for the remote sensor remote sensor data management, we wish, because especially for the petabyte scale research data, to provide the on-demand analysis in interactiveness. So we need to have a new platform to support them. So we developed we call the data bank to manage all this remote sensor, the image data. Now there are also over 700 terabytes. So each one can to browse the images. They can to analyze on the analyze interactively. So so in order to help the user to use it on the demand, not just download all this data, so we developed the Earth Data Miner. We call it it's a new online interactive data analysis environment. So the users, they can find the data, so they can write the access the data via the API, and then they can write some analysis code, even call the analysis algorithm that has been integrated in these platforms. So we provide a web IDE environment for users to use data online, and we integrate and more than one kind of algorithms to provide the service for our user to use our data. For example, this is a case for use case for support SDGs indicator computing. So we can use the data in the cloud environment, so we can upload our data, and we can write a Python code to process all the data, and we can search the data you needed from our data bank, and then you can make a SDG indicator, submit a task, and then get the visualization. So we hope the data can be used just based on our cloud environment, not just downloaded. So we provide many tools and algorithms. So for the SDGs, so we just developed a converged virtual research environment. We call the SDGs Workbench. We just launched SDG as big data platform, as just I put in the chart. So it's a bilingual, so the foreign users, they can use these platforms. So in this workbench, so we open all the data in the cases. So not only for the human users, but also for the, the programs and machine. So we integrate many data analysis tools and computer services, and even we support the cooperation. We can set up a virtual organization to, to cooperate in this workbench. So this is some interface you can see. So all the data related to SDGs, so can be findable, accessible, and you can inject to your data analysis workflow. So we provide many tools for SDGs, for the data product produce tools, SDG indicator computing tools, and even the machine learning data visualization tools. And we also integrate some open source toolkits, for example, how to process remote sensing data, how to do R analysis, and even so on. So you can use these tools, and even you can call the data in this cloud. So user can also upload their old data, and they can storage it, and they can integrate their old data with the the data commons data. So that are very good platforms to integrate platform to support SDG research. So a very brief conclusion, I think open data is a key mission of the CASAS program. And we think, except for the open data policies, the open data infrastructure, the data analysis methods, algorithms, software, and tools are also very important. They together form the open data ecosystem. Then users can use it. So we just to make a converged SDGs virtual research environment, which that can make CASAS data more valuable for the scientists, for researchers. So thank you very much, Sam.
Thank you very much, Zhenhui. Thank you, very impressive, all that work. And I thought it was particularly interesting. I'll highlight two things. I liked the guidance for your users about creating data management plans and making the metadata in order that the data could be findable and reusable. And you also made a very important point about the importance of multilingual metadata and multilingual semantics so that the data can be as widely used as possible. And those slides towards the end about the workbench and the virtual research environment for SDGs, I think was very impressive. So, so thank you very much, Zhenhui. I think that was an excellent presentation, very exciting for how computing platforms can assist open science. I'll hand straight over to our next speaker, who's Bapon Fakhruddin, who will talk about the use of open science and fair data in disaster risk reduction research. Bapon, the floor is yours.
Thank you, Simon. Welcome again. So I'll be talking directly on the open science and fair data in Earth observation for disaster risk reduction. As you can see, there is a complex relationship between this climate change as well as currently ongoing biological hazards such as COVID, as well as emerging biological hazard, how they're actually impacting our creating extreme event, and then how they're actually affecting the sectors. And obviously, you know that disaster, in a sense, is quite heavily impacting our livelihood and life, and disproportionately actually impacting our sectors. However, when you go to this some sort of this global area that looking at that how our global policy framework is actually trying to binding a data integrated ecosystem for disaster risk reduction, there are actually various framework engaged, and we are all actually running to reach a 2030 global agenda to reaching a sustainable development goal, where we are all meet today to discuss, as well as for the disaster risk reduction. There are Sendai framework, Paris Agreement, there are Addis Ababa, and all others. But all this framework actually talking about reporting back or understanding more quantifiable and quantifiable database to report back and understand how you actually progressing to achieving your milestone. But however, if you look at on the left side diagram is actually quite complex because you're looking for hour to century kind type database from, as well as we are looking at global, national, sub-regional, and local database. At the same time, we try to understand what are the hazard and its exposure as well as vulnerability in our society. But then again, there are actually multi-sectoral or multi-dimensional aspect where you're looking at ecological infrastructure, economic, social, and political environment. And having those integration on the data to understand your natural hazard or hazard risk is quite complex. Looking at that aspect, again, I mean, we just saw quite nice understanding how actually China able to actually making the fair principle and as well as, data semantic and fairness in their Sendai reporting. It's not Sendai, the SDG reporting format. But however, if you look at on the other framework, if you especially come to the disaster, they're actually more or less 30 to 40% overlapping on the data in the reporting and understanding your overall progress. And then how actually we try to compatible this Sendai monitoring as well as SDG monitoring is need to be a little bit think about. And I hope that that kind of maneuver could be possible from the Shenhui presented from the China's perspectives as well as other country, but still actually we are struggling on that aspect. Now moving to the geo database, obviously there are actually enormous data on the geospace, so satellite-driven data, which is continuously producing big data, and how that could be utilized for disaster risk reduction or understanding our hazard or understanding our risk into different sectors. This is an example we just showed in the Pacific that how much actually various sectors try to utilize the Earth observation data or geo data for their sectoral risk assessment or sectoral development plan. And you can see actually more or less actually most of the sector are able to utilize the data, but some of the sector is still actually lagging quite behind. And if you try to look at, again, on the other aspect, every sectoral data is actually continuously producing by geo community or Earth geo, but only the fundamental challenge is fairness of the data, because often actually data is not accessible, data is not interoperable, or data is not even findable for many of the government institutions because of lacking of their knowledge as well as understanding of the how to deal with this big kind of database. And often actually we don't try to see what are that actually the user they need to utilize this kind of database, and then how actually create a value chain for this data so that actually the data could be useful for them. And then from there on, how you can actually making it as a more usable data. And then from what kind of actually feedback you can provide so the data is actually used, it actually go to the local, to the national, to the global community, so that it could have a little bit coherence between the end-to-end data production versus data used perspectives. Some of the challenge I just try to compile in a nutshell. Obviously, there is a still challenge remains on the open access, and obviously quite big challenge in the fairness principle. Still, as a New Zealand, we have actually open data policy, but still we are actually struggling on the applying the fairness principle because of the organization works quite silos, and then because of the insurance as well as private industry, and data actually belongs to various entities, especially for the disaster risk reduction space. And then there are actually not interoperable, they are not actually sometimes accessible because of the privacy policy and many other aspects. There are also many countries suffering on the policy, how actually we can enhance the data policy as well as to disaster-related data. There are also problems with the progress in terms of gap in data management process, refining, digitizing, decentralization, as well as entry and organization. There are a lot of challenges in the coordination. As I said, that organization works more on silos. So interagency coordination concerning disaster-related data is quite complication. And there are also analysis and sharing and utilization has a problem. Also, the capacity is quite limited because most of the national disaster management organization, they are having a lack of awareness as well as understanding how this big data could be utilized for the decision making or understanding risk or hazard assessment. And also, obviously, the resource, there are actually quite lack of resources. Some data is you have to purchase, some could be easily accessible, but how actually those kind of data could be access and resource to storing as well as computing is quite limited. And again, when you look at the data ecosystems, there are actually various entity works in the DRR field. So there are government who actually obviously store the data, expert, DRR researcher, private sector, general citizen, as well as insurance agent. And some of them has a read and write data accessibility, some only has a read data accessibility. And that creates a lot of time challenging on the interoperability, accessibility, as well as a reusable point of view. Even though I'm saying about negativity or challenges, but there are also a lot of positive sign of it. One of the example I can just share here with the Mongolia. They have a quite comprehensive interagency data sharing policy for disaster risk reduction, where actually the NEMA, which is National Emergency Management Authority, their Met Services, National Statistics, as well as their district and regional entity work quite well to collecting the data, aggregated data, as well as creating the how that data could be utilized for hazard mapping or hazard assessment, as well as how that could be shared with like a post-disaster need assessment, multi-hazard early warning systems, how that could be utilized for GIS mapping or risk mapping, and also easily accessible from centralized data services. Similarly, a good example I could share on the big data policy that Indonesia has recently adopted. So where they actually try to create and manage a value generated from the big data and how that could be used more secure stewardship, excellent optimization, as well as using the FAIR principle, accountability and transparency, and how that data could be utilized for risk management, audit and control, and challenge defining their various sectoral decision-making and on opportunity generation. So things are happening, things are going forward, but still maybe we are struggling a bit on overall data management system. And obviously, one of the major challenge could be when you think about data, if the data is not to create any information, it's actually useless. And then the information, if the information doesn't create any knowledge, people actually will not be able to utilize that kind of information. So how actually you sort data, how you arrange the data, and how you present in a storytelling, that is quite important using the data for disaster risk reduction aspect. With these things, maybe I can just take some takeaway note or what are actually our major lessons learned from here. As you can see, especially on the DRR field or disaster risk reduction field, our institution need to be more flexible and as well as innovative. Some of the emerging data management, data research field. For an example, still many of the National Statistical Department, they still try to collect their traditional way of data collection system, but whereas actually data standardization or FAIR principle is like their bread and butter. So they could actually easily adopt some of this emerging area, how this climate change as well as disaster related data could be inherent to putting in a quite metadata standardization and putting into their own baseline data systems could be quite useful for disaster risk related community. Engagement is quite important, how actually we try to engage the user versus sector for defining the hazard definition as well as terminology, which is quite important. If we don't have a fundamental terminology or vocabulary, that would be difficult to interoperable for any data. And then obviously the fairness of the data, standardization of the data for identifying the gaps, risk assessment, as well as improving risk information. The COVID-19 actually gave us the quite strong lessons that how and why actually we need to work more on transdisciplinary manner so that our engineers, our scientists, our health worker, climate scientists, everyone need to be work together so that they make sure that we have a cohesive as well as coherence in our overall risk management as well as development plan. And as well as there is required centralized data systems, which we just saw a couple of those examples from the cost, and which is, I think, remarkable example that the previous colleague just shared. And with that kind of principle, I think we will be able to make sure that data is useful, usable, and used. And finally, I'd just like to complete that, okay, we are actually, our technology is moving quite fast. We are right now at the 4th generation, the 5th generation is coming on. So the world is actually moving from more profit from the for benefit area, and how we actually make sure that our data also can actually run to the similar pace, so that the technology, AI or machine learning, whatever actually they're producing some tangible, usable information for better decision making, or neither actually creating some underestimating information which based on the wrong database. So with these things, I think I'd like to close my session. Thanks.
Thank you very much, Bapan. And that was extremely interesting. I took away a number of things, but in particular, how useful it is to compare what is going on in terms of policy and in platforms between different countries, that we can learn across geographies, the nice examples from Mongolia and Indonesia. And I think that will feed into what I have to say in my short presentation later. And you also said something which reminded me of CoData President Barent Montz has a phrase that he likes to use, that if the data isn't fair, it's reuseless. It's reuseless. And I think you made the point very well that we invest a lot in gathering data, but if the data aren't usable, or if they're not used, then they don't find their place in that value chain, and creating those tools, those information is really important. We can't do that without transdisciplinary approaches. So thank you very much, Bapan. That's excellent, and I'll hand over to Ayona, who's another of the CoData vice presidents, and as I said before, from the Geophysical Center of the Russian Academy of Sciences, and will talk to us about open data, fair data, and work going on in the Group on Earth Observation. Thank you, Ayona.
Thank you, Simon, for this introduction. Just 1 second, I will share my screen with you. Okay, this should work. Okay, so I will probably be brief in my talk. The hat I'm wearing today is not the researcher that am in my institution in the Geophysical Center of the Russian Academy of Science. But what I wish to present to you today is the work that we do with the data working group of the GEO, of the Group of Earth Observations. This is actually an activity that is already on one side historical for GEO. On other side, this group was reworked and reorganized recently. For the moment, the data working group is convened to work with their GEO community and with external stakeholders to address data policy, data ethics, and data governance issues. And it's working based on its terms of references. GEO's data sharing principles and their GEO's data management principles form a comprehensive set of principles and technical guidance for how to share and manage data. So those principles were developed by their previously data sharing and data management working group, and now it's being reworked, and I will say some words about this. So these principles address the need for discovery, accessibility, usability, preservation, and curation of the data resources
made for available for society research and decision making. And what I hear today from other presenters and what we're actually the challenge that we face now is to avoid the cross-lapping, to avoid a cross-lapping of our efforts. I really like the slide with all the data sharing principles that we do have now, all these open data declarations and etc. And FAIR as one of the recent and the most powerful things. And we need to work out how to use these principles widely and how do they implement to different spheres. So GEO is working with their satellite and not only satellite GEO data, with all the data related to the Earth observations to improve the uptake of Earth observations for decision making. So in this way, the working group will support their translation of their Canberra Declaration, the Canberra GEO Summit, into concrete actions within the GEO work program. So you see this here on the slide. This is 4 co-chairs that we do have now. We have also 4 subgroups. So the first subgroups is the data ethics. The second is data law and policy. Then data sharing and data management principles, and the last one in situ data. So my presentation is actually probably not so colorful as the previous one, because this work is ongoing, and probably this is the first time I do present this. These 4 subgroups were formed recently, just like 2 months ago. Among the duties that we have defined is, first of all, to monitor trends in international open data and data management practices, as I already said, to avoid overlapping, to build the bridges, and produce trend analysis and recommendations, to revise GEO's data sharing principles and GEO's data management principles that were developed quite a long time ago. The second is to continue to promote the adoption and implementation of these principles within GEO community and globally. Then to advance discussion of critical data related topics with the stakeholders communities, recommend ways for GEO to advance the interoperability of Earth observations and complementary data. And I personally think that this topic is one of the most challenging and one of the most important for GEO activities, because Earth observations interoperability is still a big issue for many communities. And I can give an examples from my daily work as a researcher. We work with the interoperability of the satellite magnetic data and in situ magnetic observations from their geo monitoring stations. And this is always it's challenging because it's a quasi real data or real data, and it's a big data. So we have so many things to solve here. And the last one is to identify, analyze, and describe best practices. So I will speak just briefly about each subgroup. I will speak about this because I have the goal. I wish to present it to this wonderful group of people, and probably I will see some possible participants for our subgroups. So please let me know if you're willing to join us. For the data ethics and data law and policy subgroups, it is actually 2 subgroups. We have 2 main activities that are planned. It's the first one is a cloud computing ethics and privacy possible challenges. So to analyze the main legal, privacy and ethical issues when we're using cloud computing platforms. So among the main topics is ownership and security, and that was also always crucial for geo community. Then the openness, transparencies and portability topic, and etc. The second is legal interoperability of shared data, and we have some we have already produced within GEO some reports, and the main goal is to revisit it and present one concluding report that we will probably post in 2022 as a result of our work of this subgroup. So the second one is in situ data subgroup. This in situ data subgroup is a component, important component of the data working group, and it has been formed to bring together selected experts to focus on topics of different relevance to the in situ data community within the context, the general context of GEO. And GEO has historically recognized the importance of in situ data, including the necessity for this data in order to calibrate the satellite-based Earth observations, as well as relevant simulation models. Coming back to their example that I made from my work in related to geofields, related to the magnetic data, it is always a crucial moment when we try to calibrate their in situ data with their satellite magnetic data that is not actually this quite temporal, and the model data of the Earth's magnetic field. So the key actions that we have defined, the first one is to understand the in situ data landscape within GEO and beyond GEO. Then to promote a more coordinated approach to in situ data management, and as well as to encourage good data management practices and to adopt fair and open science principles. And their third one is to highlight the benefits derived from the integrated use of the diverse range of in situ data with Earth observation data. And then the last one subgroup is a data sharing and data management principles subgroup. This is the subgroup that was formed based on the previously existed working group of GEO. We see here, we propose here 3 activities. First of all, to describe the status of implementing of the GEO's data sharing principles and GEO's data management principles, and actually to rename it finally. Then to determine how the uptake of these principles may be furthered, and to address changes in the context of open science. The most important thing is to provide this cross bridge up to interlink fair, trust and care principles to connect with the other subgroups as well, and not only within the GEO community, but abroad. We have joint coordinated and made a joint coordinated analysis of the GEO's platform operation team. We have provided a review that was a part of the GEO working program activities with the specification of in situ and satellite data. analysis was done, and our team is expected to report on it by September this year. Coming to the summary and to my last slide. Our aim is to highlight open science as the path, not just science more openly conducted, but more collaborative, and bring a second scientific, like as we call it, to bring a second scientific revolution. Then to currently a mix between definition and description of the goals of open science, to provide a clear definition, why open science is desirable for GEO community. Research outputs must also be findable, fundamental for reuse. Coming back to the quote from Baron Moons, it's essential. References the International Science Council and CONDATA, in addition to UNESCO, to their published data principles. And provide a consideration for the secure environment where data and research fundings are protected properly. That's, I think it's a crucial point, especially as we're coming for more and more open research projects. And among our goals is to publish these documents in a less formal way. So we are actually have an idea to rename it from GEOs to GEO, data sharing and data management principles. This preliminary version serve as a provenance of new documents, and we're working to make it as transparent and as open as possible. Then to describe the values of and relationship between several data principles beyond fair and trust, to build this crosswalk between these principles so we can see where are there overlaps, where are the benefits, what are the benefits, what are the gaps, what are the barriers. I think it's essential to build this crosswalk to the information lifecycle, so data providers know when and why do apply various principles. And this is needed as an argument for the value and importance of the data sharing and data management principles as open and applicable frameworks. Then to compile these principles from the document that been developed quite a long time ago as a baseline, and highlight the linkages and value regarding the care principles based on the GEO Canberra declaration. Incorporate state-of-the-arts of this data sharing and data management concepts as well. Its adoptions into the document, again, emphasize the influence of expertise that we currently have, and to publish it as a collection of the documents in spring 2022. So this is it. This is what we have developed in quite a short way. We are looking forward to their next GEO plenary session that will be held online in November this year. And as I already said, I'm very happy if you will wish to join our group. So thank you very much for your attention.
Thank you very much, Iona. I particularly liked the way that you brought your own experience as a scientist into that presentation and discussed the concrete and real issues of interoperability that you encounter in your daily work as a scientist, as well as in your work with the GEO data group. And I think it's also important to point out to participants that invitation to participate. The GEO community does invite from its member states and from its associated organizations participants in those activities. And please get in touch with Iona about that. So we'll conclude this session. The final presentation I'll give myself, and it's an introduction to the Global Open Science Cloud Initiative, just bear with me one moment, and hopefully you can see my presentation there. So I'm going to talk about this, the Global Open Science Cloud Initiative, which builds on a project that Jean-Louis, our colleague at CNIC, runs. It builds on that project and it aims to expand it more globally. So that project itself will have more impact, and I'll explain how we're doing that. First of all, I should introduce myself, as I did earlier, Simon Hodson, Executive Director of CODATA, and introduce CODATA as well. So CODATA, our full title is the Committee on Data of the International Science Council. We're not just a committee, we're a legally and financially independent organization, but we exist to serve the mission of the International Science Council to advance science as a global public good. And we do that by promoting open science and fair data. So our mission, we sum that up as connecting data and people to advance science and improve our world. And our membership is based upon national organizations, on international scientific unions and other organizational members. But we have 4 strategic activities, or 4 strategic themes under which we class our activities. We do a lot of work on data policies, so things like this independent review of the CAS Earth data policy. We do work on data science. We have a data science journal. We organize regular conferences, and we have technical task groups and working groups. We do a lot of work on data skills and data education. We have a series of schools, we call them there, 2-week workshops or online workshops to train young researchers in data science. And we do various activities like that around the world. And in this 4th pillar, we call Making Data Work, or rather Making Data Work for Global Grand Challenges. And I'll say a little bit more about that later, but that's what we call a decadal program. So it's an initiative that we expect to last at least 10 years, and it's our key strategic activity to better enable the combination, so that's the integration, the interoperability and reuse of data for grand challenge research areas. And the Global Open Science Cloud is a key part of that. So what do we mean by a global open science cloud, and what are we trying to achieve? So I'll talk very briefly about a little bit of history. So we see in the modern world a number of open science or open research clouds or platforms or commons emerging. And they exist for a number of reasons, and they build on existing infrastructures. So historically, we've often had domain research infrastructures. Some of these start in 1958 with the International Geophysical Year and the creation of the World Data Centers for geophysics, for the domain that Iona works in. And then individual countries developed national discipline-specific data services, and then some of those started serving international needs. And you have strategic processes in a number of countries that you can look at as well. In Europe, there was a thing called the ESFRI process to decide what are the research infrastructures that we really need for the science of the late 20th century and the 21st century. And there's been a similar process in China with the establishment of a number of key data centers for particular research areas. Similar things in the US, in Australia, they have the NCRIS program, etc. So you start to develop these infrastructures that serve the needs of particular domains. At the same time, you have what we might call open science or e-infrastructures, which provide transversal services which are necessary for science. Things like the network or high performance computing. So NRUNs and e-infrastructures. In Europe, we have EGI. And so in the early 20th century, policymakers and scientists are beginning to think these things need to be increasingly combined. We need to try and link up better those e-infrastructures with the research infrastructures that we've developed. And it's also important that those research infrastructures shouldn't just be silos, that we should start to work across those domains. So we see the emergence of these open science infrastructures, sometimes we call them clouds or platforms or commons, which try to be full stack. So to link those e-infrastructures, the network and the high performance computing with the research infrastructures more effectively. And they try to work across domains to better enable data sharing between domains and sometimes contiguous domains. So in environmental science, you might want data around the environment, but also data around biodiversity and data around the human interaction with the environment. And so you start needing to combine data from different sources. And there's a number of different drivers for this: economies of scale, greater impact and effectiveness of science, greater interoperability, and also the desire to advance this principle and this vision we have of open science. And there are a number of examples of this around the world: the European Open Science Cloud, the China Science and Technology Cloud, the Australian Research Data Commons, et cetera, et cetera. So in various countries and various regions, there are these initiatives. And so the Global Open Science Cloud Initiative is designed to work to encourage cooperation, alignment, and interoperability between these initiatives. And we're motivated by a number of factors. We've already heard about the UNESCO recommendations, and I mentioned that CODATE is part of the International Science Council. So the International Science Council has developed an action plan, and within that action plan, there are two particular areas which CODATE has been entrusted to lead or contribute to. One of these is action plan, the part of the action plan 4.4, which encourages the creation of national or regional open science platforms, particularly in the Global South, to position scientists and science systems in the Global South at the cutting edge of data-intensive open science. So CODATE has been working with the International Science Council to encourage the African Open Science Platform, to advise the Malaysian Open Science Platform, and our Global Open Science Cloud Initiative falls under that. And this corresponds to recommendations. We see this as a way of our responding to and helping to implement the forthcoming recommendation, the UNESCO recommendation of open science, which says in one of the sections on implementation that we should encourage north-south, north-south-south, and south-south collaborations to optimize infrastructure use and joint strategies for shared multinational, regional, and national open science platforms as a way of advancing open science. And so our collaborators in China, CNIC, will be setting up an international program office as part of the CODATE decadal program to promote that Global Open Science Cloud activity. So as I said, there's the CAS-funded, the Chinese Academy of Science-funded project at CNIC, which is providing secretariat support and project resource. And then in collaboration with CODATE, we're trying to expand and build on that project and obtain genuine international engagement. And with the objective of encouraging, as I said, cooperation, alignment, and ultimately interoperability between those various initiatives around the world. And we aim to do this through thematic working groups and detailed case studies, which I'll go on to explain very briefly. We've set up a steering group, and we've just launched in the last few weeks the working groups and the case studies. And our approach is that there are 4 transversal working groups looking at particular themes. So what motivates these initiatives? What's their strategy and governance and sustainability plan? And how can we learn from that? What are the policy and the legal issues that they're trying to address? What are the shared technological infrastructure issues that they're addressing, that they're the challenges that they're facing? What are the shared technologies that they're using? And can we get alignment there? and also issues of data interoperability, of course. What is the metadata we're using? What are the semantics we're using? How are we describing the data? And can we make it easier for people to take parts of the data and combine it in order to advance their research? So those are the four cross-cutting themes, if you like. And then at the same time, we have what we think of as 5 initial vertical case studies, and they look at particular scientific domains and examine how those scientific domains are facilitated by open science and by collaboration between the open science clouds or platforms. So we're taking those case studies and exploring whether there are recommendations we can make to improve collaborations between the clouds, improve the technology that's being used to better facilitate those research areas. The 5 case studies are in incoherent scatter radar data diffusion, in biodiversity, in SDG 13, climate change and natural disasters, which I think is of particular interest to this audience, in sensitive data federation, which is a very difficult topic on issues of population health and clinical data, and also a newly proposed case study on raw diffraction data, particularly proteomics, or in relation to protein structures, I should say. We've proposed a methodology for the working groups and the case studies to explore the landscape, to identify the challenge, to think of possible solutions, and ideally also to try and implement and test and refine those solutions. And the ultimate output will be recommendations for the open science clouds and for the wider community, and ideally some pilot implementations of any technology or recommendations that have been developed. Over the next 2 years, the working groups and the case studies will be presenting at a series of conferences. I'm not going to go through all of those, but the presentation will be shared out of interest, but it's worth pointing out that we've got sessions coming up at the virtual SciDataCon, which will be in October. We'll be presenting at International Data Week in Seoul in June 2022, and pandemic permitting, we'll also be running workshops at the main event for this project and initiative, the International Symposium on Open Science Cloud, which we hope will take place in Beijing, perhaps in September 2022, maybe a little bit later. But we'll be planning that series of events in order to keep the progress with the working groups and the case studies, and to tell the wider community about what's going on in this initiative. If you're interested, you can find out more about the initiative at these links. There's an overview, a short paper on our objectives. There's an introduction and launch event, which we ran in June, where we explain in more detail the vision of the Global Open Science Cloud project and initiative. There's presentations and recordings. You can, if you're interested in the working groups or the case studies, you can sign up at that bit.ly link. And there's also a capacity, if you work in a particular research area and you think it would be good to collaborate with scientists in different countries to work out how between open science clouds or platforms you can better share and exchange data, you can propose new case studies at that link there. So that was, I hope that was a useful, quick introduction to the Global Open Science Cloud initiative. Thank you very much for your attention. And I'm trying to stop sharing my screen. I think I've succeeded now. So thank you very much. I think we can, I think, Wenrong, can we spend a few minutes with any questions or discussions? I think we've gone a little bit over time, but hopefully we can respond to any questions
I think she said
Hello.
yes first.
Yes.
Hey,
Okay.
sorry, I didn't notice that I muted myself. Sorry. Let's move to the next section, discussion part. Okay. Thank you very much.
Okay. Okay.
Um,
So are there any questions from participants? You can use the chat tool or the question tool to raise those, or even you could raise your hand to speak.
Yeah, don't hesitate to raise up your hand so that we can put you on the stage. Do you have any questions about open science, open data, fair data, or something about, say, data management, or about SDG? Okay, so
Yes,
just
we have a raised hand. I think that's it says Yude Liu, but I think that's my colleague Lily Zhang, who appears under that name sometimes. Is that correct? Anyway, when wrong, if you can
Hello.
unmute.
Yeah. So IT staff, 那个 IT 老师，你们帮我看一下那个有没有人举手呢？
Okay, I've managed to unmute the participant.
可以帮我下上麦吗？
Hello everyone, this is Lily. Yes, I just take my colleague's account for the Zoom. This is Lily from CNIC, and this question is for Anna from UNESCO. Just briefly to introduce myself, I'm also engaged in the GOSC initiative, briefly introduced by Simon. So within this initiative, we will have the development of the global open science cloud. I think this one will surely follow the UNESCO open science recommendation. So my question is, if we just start from the international organization perspective, how would you foresee our engagement for the UNESCO recommendation, and how to get us really closely engaged into that? Thank you.
There are great, thanks. Thank you very much for the question, and I know that the initiative is on its way, and we have actually been part of the discussions that you've had. I think even from the beginning, when my director was Peggy Otiboateng, was attending one of the first sessions for the Global Open Science Cloud. And I would really, it's really important that we do keep this, this close connection also going forward. There are certainly different ways in engaging. One is through the member states and through their own implementation strategies for the recommendation. The other one is through the Secretariat also, where we promote activities that and we will be engaging in activities that support the implementation of the recommendation. So different ways in which to work together, different ways. As I said, we are working on an implementation plan that we would like to roll out after the adoption of the recommendation, where we would like to see different partners and different initiatives and how they fit into the implementation of the recommendation. And then we have a mechanism of actually reporting back to the UNESCO General Conference every 4 years, because it's a standard setting legal instrument of UNESCO. So member states are obliged to report back. So there is also a monitoring mechanism that will also allow for different member states to understand what is happening, including these big international initiatives which are taking place. So we just have to be in touch through Simon or through other colleagues who are involved in the Global Open Science Cloud, and see how to bring it together and forward, including in the context of the implementation of the recommendation.
Thank you, Anna. I've just put in the chat, yes, Peggy she gave a keynote presentation at the Codata 2019 conference, which was held in Beijing in September 2019. And she attended the workshops, really, which were sort of led to the GOSC initiative and project. So that link is very strong. Something that I'd like to see us doing, and clearly in collaboration with UNESCO and under that umbrella. What we aim to do with the Global Open Science Cloud is to create recommendations, show good practice, and learn as well. And to use the UNESCO platform to assist our cooperation and alignment between these initiatives globally would be fantastic. So we hope that the Global Open Science Cloud can contribute to that, but also that we can use the UNESCO platform to share knowledge between initiatives and to act as a good example, but also to learn what is good going on elsewhere. Absolutely. And that goes back to some of the points that Bapon made about the strengths of activities, the join up of activities in Mongolia and the Indonesian platform, as well as the impressive presentation from Jean-Louis.
I think that in general, the sharing of best practices and lessons learned of what works and what doesn't is extremely important. And we really do hope that UNESCO will be able to be the platform where these experiences can be shared going forward as well. Yeah, sorry, I see that also Bapon has his hand up. I don't want to take up the space.
I was looking at the attendees, not the panelists. Yes, so sorry, Bapon, I missed your hand. Bapon, please go ahead.
I just have one question to Shen-Hui. I mean, I really enjoy your presentation, and I also see the comprehensiveness, actually, the SDG reporting platform that you created. I'm just wondering that how about for the Sendai reporting system? So you have the similar system in place in China, or is this actually managing by other entity or other organization? As you saw that there are actually 40% data is actually common between the Sendai as well as SDG.
Thank you. Yes. So this platform just developed this year. It's from bring from the CASERS program. As you know, Professor Guo is a leadership for the CASERS, and in the future, so the program will focus on the SDGs, the indicator analysis and the researches. I think now in this stage, we are open to all the the scientists in the CBAS Center, and actually CBAS it's an international research center. We will provide service to all the scientists. We wish, just as Professor Guo mentioned, in the future, we wish 30% scientists will come from the international partners. So we just build the facility, and we build the research environment. So we are open to all the scientists from the international partners, so they can join us research. Just as you mentioned, so the SDG 3, you send email, the SDG 13, the use case in GEOSC. So this is also linked to these platforms. So we will cooperate to build a new platform and even to provide service to support specific on the SDG 13 researches. Many firstly we will focus on the East and Asian, and then we will focus on Africa and the other countries. So it's open, but it just start. Even the center is just start to run yesterday, and maybe we the Chinese government think it's a key issue for government to support the UN's SDG goals. So I think in the future we'll have more cooperation on these issues. Okay, thank you.
Thank you, Jean-Louis. Thank you, Bapon. Ayona, please come in.
Yes, thank you very much. I just wanted to say that I think that's for a new person to come to new initiative to be launched, it is extremely important to provide an expert document from such an expert as we are that will help to navigate between all these practices. We face it daily, and we face it on different levels, starting from the basic researchers that actually they wish to be open, they wish to be fair, and etc. But they see so many different declarations, principles that they are, unfortunately, sometimes are doing their own and they do not follow one of the existing, and this become chaotic. And I think that we made so many wonderful presentations from very different points of view, and for all of us, it's very important to joint efforts in providing this unique feedback.
Thank you, Iona. Yes, I think we do have to always think about scientific culture and the benefits that people feel. But we can show lots of examples of people engaging with international collaborative projects in getting citations, for example, for their data. And through such activities, the culture of science gradually changing. But it is a process. I think, I forget which speaker said it, but open science is a process rather than a goal. I think it may be more than one of our speakers today said this. And I think that's something worth reminding, that it's a process that we're in the middle of. This culture change, these changes of policy, these changes of scientific practice, the changes of technology. This is all happening around us. We can see how much the world has changed in the last 5, 10, 15 years even. And that's true of scientific culture as well. So do we have any further questions? It would be great to have a question from the floor, from the audience, as well as from the panelists. Okay, seeing none, I'm going to ask a last, or maybe last question of Anna. So we hope that the could you tell us more about the General Assembly and the process there, and how you see that unfolding to get the recommendation approved?
Yeah. Sure, no problem. So we're talking about the General Conference of UNESCO. Mm-hmm. The General Assembly is at the UN in New York. This is going to be adopted at the level of UNESCO. So it's the General Conference. It's the same member states. So it's still a very high level. It's just a different governing body. As you know, Simon, we went really through a very, very large consultative process with a lot of people who were involved, including the governments, etc. We had an intergovernmental meeting in May where the governments were able to send their experts, technical and legal experts, and they negotiated the text as well. That text, negotiated text, has been adopted in May by consensus. That is the text that is now going to the General Conference. So we are hoping that the member states will not reopen the document, because actually they did have the opportunity to comment through their legal and technical experts in the advisory committee, in the intergovernmental meeting. However, it still is a moment where the member states do have the opportunity to have a look at the text. If there is anything that they don't like, it can still be discussed. Again, we did not hear that there are some member states particularly concerned with the text as it is. As you know, and you've been part of these negotiations, it was extremely cooperative and constructive, very, very good atmosphere, and I think the member states want to stay in that vein. So we are not foreseeing any major difficulties, but you can never take anything for granted, and there is something, it can come up in the discussions of the General Conference. But as I said, we really are hopeful that it will not get reopened, and if it does, that it will not completely change the nature of it, because
it will not change it over dramatically, even if it is reopened. And we'll then have a UNESCO document that we can point to and say we're seeking to implement these recommendations.
And that's exactly what we would like to then encourage everybody working in the open science field to do, and that is, that document is there really to support your work. It doesn't mean that you have to switch and do something else because the document exists. It's actually the other way around. It will help you continue doing your work and have something to point and say, yes, we need the funds, or we need this and that. Look, there is this new standard setting instrument at the international level. Our country, your country has adopted it. Therefore, they will have to implement it. So really use it as a reference document, as something that helps you leverage what the good work that you've been doing so far. But we also do hope, as Alena was saying, that then we use a little bit more, the UNESCO to possibly put together some kind of guides, to have some kind of idea of some harmonization of certain practices, or at least pointing where different things are, who different experts are, etc., to make sure that there is more and more coherence in the practices that are being done around the world.
Yes, I think those guides and those examples are really important. On that theme, if I've got time, I'd like to ask one last question of Jean-Louis, because we saw from Jean-Louis a very impressive presentation of the data platform being built. I particularly like the screenshot of the catalog page with the permanent identifier, the persistent identifier, the metadata, the knowledge graph, the ways of accessing it, the APIs to access it computationally. This was extremely interesting. And then the other slides on the computer tools. But it would be great to have sort of concrete demonstrations of how those data are used and how it's turned into a tool for policymakers or a tool for scientists, how we can extract from those data the information that can be then used in policy. And I wonder, Jean-Louis, when could we have a demonstration of that? When could we work with partners to show the impact of that approach and to look at what the system and what those data can tell us about the SDGs?
Simon, I think it's a very it's a good questions. Before that, before this year, so we just we connect the research data, and we manage it, and we just publish it. So we don't know who uses it, how to. Yeah, this is the question. So in this year, so we wish we can focus on the SDG researches. So this is why we try to establish a integrated workbench for our research teams. So we wish we can make demonstration this data can used by the research teams for example, the SDG 13, the SDG 11. So how to use it? They will tell us how to use it. So they will assess the data quality. They make assessment about your tools if it's suitable for us. So I think the platform just published, and in the next 6 or maybe a half years, we have a plan to cooperate with several research teams on SDGs. So we will try to get their requests their requirements and try to, you know, improve our platform and help them, they can use it. And just as you mentioned, we demonstrate this. Yeah, it can be support the SDG research, but it's in our plan. Maybe we need a more 6 or maybe a year to, you know, to demonstrate it.
Okay, so it would be good to have those good practice demonstrations and those findings sometime soon, and maybe we can organize a workshop where we do a show and tell or something like that.
Yes,
that would be good. And also that will be a topic of the review that ITONG is part of as well, to understand how those data are being used. So I'm going to wrap up this meeting now. I know it's 2100 in Beijing. It's 1 in the morning in New Zealand where Bapon is. So particular thanks to Bapon for his participation. I'd like to thank our hosts and Wenrong for organizing this. I'd like to thank all the panelists for your presentations and your inputs. And thank you very much to those of you who've been listening to these presentations and the discussion. We hope that was helpful and informative about open science, about fair data and important initiatives globally. And we look forward to further discussions. Please do get in touch if you want to get involved in any of the initiatives that we've been talking about, in particular the Global Open Science Cloud Initiative, and watch what's happening with the UNESCO recommendation. Thank you very much.
Okay, bye. Thank you. Thank you very much.
Thank you. Thank you very much.
Bye.
Thank you.
Bye.
Bye.
Thanks, Wenrong. I have to go to another meeting, but thanks very much for organizing that. We'll see you soon.